Hello, grade 11s. In this video, I'm going to go over how to do a stoichiometry question. This worksheet is posted online. It's called, you can see at the top here, it's called the Stoichiometry Extra Practice. It's in the form of a PDF. And we're going to go over question 7. There are great examples in this worksheet. Several of them I wouldn't suggest you do right now. It's great as review for your unit test, which should be roughly in about a week or so. All right, but we'll talk more about that later. So we're going to do question 7. Okay, so I'm going to flip between this screen and my writing screen. Okay, so question is asking how many grams of carbon in this reaction will be consumed when 5 grams of sodium sulfate right here react according to the balanced equation shown. Right, so this is a fully balanced equation. One less thing to do, not have to worry about balancing. Let's write this here. Okay, so we have sodium sulfate, and I believe there are 2 carbons. Right, 2 carbons, yes. And then we have Na2S, and it's 2CO2 plus 2CO2. Okay, so fully balanced equation. Now what I'd like to do is then organize information we're given. So here we have 5 grams of sodium sulfate. So let's write that down. Make this into the form of a table. This should help you organize your information and then figure out what to do next. So 5 grams of sodium sulfate. And I calculated the molar mass using a periodic table, and it's 142, I believe it's 142.07 or zero 0.03, but we'll just leave it at 142 grams per mole. Okay, what else are we given here? 5 grams of that react according to the balanced reaction. We need we need the mass of carbon. Right, so question mark here, we need the mass of carbon. So this is everything we're given. Yes, this we weren't given, but it's something that we can figure out by looking at a periodic table. All right, so 142 grams per mole. Okay, now, as the saying goes, when you don't know what to do, and even if you do, always figure out the number of moles. Whenever you're going from one value to another, so whenever it's asking you to consider one thing and then figure something else out from that, you have to figure out the number of moles. So always print the number of moles. Okay, so moles, how do we do that? So we can do this a few different ways. You can use a formula or a fact label method, and we'll do this question using a combination of the two methods. So these are the number of moles. Okay, well we have 5 grams, right? We're going to divide that by 142 grams per mole, and that gives us 0.0352 moles. Okay, I usually like to keep at least 4 or 5 digits. Don't round while you're doing the question. Your answers will not work, even though your process will be correct, and you might get full marks for your process. The final answer would be off, and that would be a mark off there. So that is the number of moles of sodium sulfate. Now, whenever you go from moles of one thing, right? Whenever you go from moles of one thing to moles of another, that's essentially stoichiometry. And this involves a really important mole ratio. Okay, and because we're comparing these two, in this case, the mole ratio is a 1 to 2 ratio. Now, because it's simply 1 to 2, you can almost do this in your head or really simply on a calculator. But let's work this out, show our work. It's important always to show the work. As we continue to do more of these examples, I'll show you shortcuts on how to do a question like this a bit easier or a bit faster. But in the meantime, we should really always show your work. Let's use a fact label method to solve this. Okay, I'm going to scroll down a little bit and we'll go back up. So we're figuring out the number of moles of carbon now. So we need the number of moles of carbon. So let's write down what we need. Scroll down further. Right. So we need the number of moles of carbon. Right, this is the fact label method. Then we are given, or we've determined, the number of moles of sodium sulfate. Okay, now we're going to multiply that by a conversion factor. Now we should at this point hopefully know that that conversion factor is your mole ratio. But let the factorial method work it out for you. Write down the unit you want to get rid of, so that's right here. And the unit you want to keep is right here. So moles of sodium sulfate go at the bottom, that's what you want to get rid of, moles of sodium sulfate, and moles of carbon are what you want to keep, and that goes at the top. Now this is a mole ratio, so let's go back to our balanced equation, and we got to figure out what numbers are associated with each of these units, with each of these descriptions here. So mole of carbon, that's 2. Mole of sodium sulfate, that's an imaginary 1 there, so it's 1. And that is your mole ratio in a factor label setup. Try scrolling down here, it went too far. Okay. Essentially what you're doing here is just multiplying by 2. Okay, I'll show you in this video, actually, what I want to show you now, how you can do this a bit simpler without having to use a factorial method, but also by showing your work. It's important to show your work whether you use a factorial method or not. Okay, so watch, units cancel out as they should, and we multiply this by 2, and we get 0.0704 moles of carbon. Good. So you don't have to fill in this table as you go along, but I think is a good idea. We now have the number of moles of carbon, 0.0704 moles of carbon. But it's not really, it isn't what the question's asking us for. We are missing mass. So now the question just became a mole conversion problem. So we're going from moles of carbon, which we now have 0.074, to moles of, rather to grams mass. Okay, let's do that. Got to scroll down a bit. Too far. Okay. All right, so now let's use our formula here. Okay, so mass is equal to moles times molar mass, so 0.0704 moles of carbon times a molar mass of carbon. Use your periodic table to figure that out, just refer to it, and it's 12 grams per mole of carbon. Notice units cancel out, and plug that into your calculator, and you should get 0.845, and I've rounded to 3 sig figs, 3 significant digits here, because our question has 3. 1, 2, 3. So our final answer is, let's go back to the bottom, is this 0.845. Okay, I told you I would show you a different way of solving that stoichiometry part, so let's go ahead and do that. What should we, let's just choose green. Okay, so an alternative, so I'm going to write or, an alternative to using a factor label method when it's a simpler ratio perhaps, is since and therefore statement. So as long as you show your steps, show your logic. So you can say since the ratio is 1 to 2, right, and since number of moles of Na2SO4 is equal to 0.0352. Therefore, number of moles of sodium sulfate times 2 is equal to the number of moles of carbon, right? So the number of moles of carbon, you would just plug that into your calculator, is 0.0352 times 2, and we get the same answer, 0.0704. Okay, moles of carbon. So if this method, these since and therefore statements work for you, or if you prefer then to stick with the factor label method, that's great. You just need to show your work, right? So your upcoming test will likely have a combination of multiple choice, certainly communication questions that you have to write answers for, and then another part to it, and figuring this part out, probably have to take a picture of your work or show your work somehow like we did in this video. So hope that helped. Continue asking questions.